So just a very quick reminder, f of x increasing. It means that we're looking at as the x values get larger, what happens with y value. The y values get larger as the x values get larger. And so you're looking for where the curve is moving up. What are the intervals where the curve is moving up? And so I'm going to trace that here. It's increasing here, 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 here. So I get to this point, and it's okay if you estimated it visually. If I actually trace the curve with my cursor, it looks like right up here at about negative 1.826. Many people put -2, and that's perfectly fine for what we're looking at here. So negative infinity to negative 1.286. And then the curve starts decreasing until I get to this point. And then at 1.8, oh, that's negative 1.826. And then I look at 1.826 to infinity because the curve is starting at x equals 1.826. The curve starts moving upwards again. And almost everyone has put that or something that's close to it. And then question 2 is really easy because it's the same question, not repeated. But then if I move forward and I ask, where is f prime of x positive? Now I look and I say, where is this tangent line positive? So for instance, if I sketch the tangent line at -5, it looks something like that. And that's definitely a positive tangent line. So it is the case that prime of -5 is positive. And I'm asking, what are all the x values? What are all the intervals, all the x values where anywhere that I sketch the tangent line at that x value, I'm going to get a positive answer. What did you notice? Turns out to be exactly the same. I didn't erase anything for a reason. If I look, where is the slope of the tangent line positive? That means where is the curve moving upward? It's the same thing. So it's exactly, these are exactly the same points. And so this is encapsulated in a mathematical statement called a theorem. And there are lots of different ways to describe a theorem, but a description I would give that I think works for this class is a theorem is a way of knowing something automatically. It's a mathematical statement that is always true. And so the goal of having a theorem like this is to be able to just know something is automatically true and reduce our level of calculation. In this case, what we're doing is we're moving from one type of work to another type of work. Can you tell if f of x is increasing from a graph? Yeah, very easily, right? What if you don't have a graph? What if you need to do this in a purely symbolic or numerical way? And our questions where drawing a graph isn't possible. So what we're doing is we're taking that knowledge that we have if we were able to look at the graph, and now we're saying, can I tell if f of x is increasing from its derivative, f prime of x? And the answer is yes. How do I know? I know that f of x is increasing on an interval if f prime of x is positive on that interval. These are two different statements about f of x. One of the statements is that f of x is increasing, and the other statement is that f prime of x is positive. But we're saying that if this statement is true, so is the other one, and vice versa, that these two things are equivalent statements. So does this statement make sense to you, regardless of why we would care or anything? You understand what this is saying? Well, let's get that initial understanding, and the next thing is to try to apply it so that it becomes more permanent. Here you're asked to find all of the graphs that have f of 0 positive and f prime of 0 negative. Notice that this is totally possible. This is totally possible. The sign of f prime doesn't tell you anything about the sign of f. Rather, the sign of f prime tells you about the direction, the slope of f. So right here, 0 is positive because if I look at x equals 0, I have positive y value. But then I look and I say, what about tangent line at 0? What does that look like? Well, the slope of the tangent line at 0 is negative. So this graph would work as an example of this, where f of 0 is positive, but f prime of 0 is negative. Are there other examples you see that work? One right next to it also works. Notice these two graphs look really different in terms of their large scale property. But what matters for these questions is only what's happening close to x equals 0. And that's one reason we spent so much time thinking about limits, or why it was so important to think about limits, is because doing limits helped us think about zooming in and not worrying about the big picture of the graph, but just thinking about what happens close to a particular number. Now, hopefully the right answer matches what we just said. Do y'all agree that these are the two correct graphs. Well, they're reshuffled, but it's the same two graphs. So this statement that we wrote only covers increasing functions. I'm going to ask you to come up with a statement about decreasing functions that mirrors it. And then to make some of your own, to trace and show that you know what f prime of x positive on an interval looks like. And then to come up with something where you have specific height properties for a graph you create. And then finally, to be something very open-ended. These are nice practice exam questions for Thursday's exam a week from today. You definitely want to be able not only to recognize the relationship between f of x and f prime of x, but also to use it to make graphs that satisfy certain properties, just like you did on the first exam. All right, thank y'all very much for being here. If you have any questions, please let me know.